We're now going to take a look at infinite limits. Now, infinite limits occur when a function approaches positive or negative infinity as x approaches a limiting value c. Now, these are important to consider because they tell us a lot about the behavior of a function and what its graph looks like. So we're going to take a look at some examples that detail how we can evaluate infinite limits. So let's start by considering this function, f of x equals 1 over x minus 1 squared. Now, down here we have the graph of that function. And you notice that as we let x approach 1 from the left, notice how the function goes upward towards positive infinity. And the same thing as we let x approach 1 from the right, the function breaks upward towards positive infinity. We can also see this from a graphic like this. Notice if I let x, which is the dot on the x-axis, approach 1 from the left, notice how the dot on the y-axis will approach infinity. See, it's getting larger and larger. Eventually goes off screen. And the same thing if I let x approach 1 from the right, that red dot moves off towards infinity. Alright, so what we have now is this. We have that as x approaches 1, the function is approaching infinity. We see that from the graph. So it's perfectly fine to write that the limit as x approaches 1 of f of x does not exist. But this is a special type of does not exist. And we're going to specify it like this. We're going to write the limit as x approaches 1 of f of x equals infinity. Now, writing it like this gives us a little more information about what the limit is doing as x approaches 1. It tells us the function is going up towards positive infinity as x approaches 1 from the left and right. And it also gives us a little bit more information about what the graph looks like. Okay, we know the graph has a behavior like this, illustrated over here. Okay, now we could write the same thing for negative infinity and left and right hand limits as well. So let's take a look at this quickly and try to understand why is the limit as x approaches 1 infinity analytically, and then we'll look at some more examples. So if we look at the limit as x approaches 1, like that. Alright, now it's pretty easy to see that this is going to go to infinity as x approaches 1 if you think about it like this. As x approaches 1, the top is approaching the number 1. It stays fixed at 1, right? So of course it's approaching 1. Now, what is the denominator doing? Well, as x gets closer to 1, it's taking on values like 1.1 or 1.01, or that's from the right, or from the left 0.9, 0.99. And if I put those numbers in here for x, and then I square them, that's going to give me a very small positive number. Because of the 2 here, because I'm squaring it, I'm going to get a small positive number. So this is approaching 0 from the right. Okay, so what this function is behaving like, it's behaving like 1 divided by a very small positive number. Now 1 over a small positive number, that's going to be a really large number. That's going to infinity, right? You know, you can test that. If you evaluate 1 over 0.0001 on your calculator, you get a very large positive number. So this limit is infinity. And that's how we can quickly analyze what a function is doing at an infinite limit. We look at what the numerator is doing. Is it approaching a number? What is the sign of that number? Is it positive or negative? and then we look at the denominator and see how it's approaching 0. Is it approaching 0 from the left or from the right? And that'll determine whether we have a positive or negative infinity here. So let's take a look at a few more examples to clarify this. So let's take a look at this one. Let's evaluate. Let's say we're given this function first. So we're given the function negative x divided by x minus 1 cubed. And we want to evaluate the right, left, and full limits as x approaches 1. Notice that for this function, if I put 1 in the denominator, I get back 0. And if I put 1 in the numerator, I get back 1. So since we're getting something like 1, So since we're getting something back like 1 divided by 0, that indicates that we're going to have some type of infinite limit as x approaches 1. So first of all, the right-hand limit, well, let's write this as the limit as x approaches 1 from the right of negative x divided by x minus 1 cubed. Alright, now as x approaches 1 from the right, that means x is going to take on values like 1.01. Now if I plug 1.01 into the denominator, 1.01 minus 1, that's a small positive number, and then I cube it, that's going to be an even smaller positive number. So the denominator is approaching 0 from the right-hand side. Okay? Now what's the numerator doing? Well, the numerator is approaching negative 1, right? So what is happening here is this is behaving like negative 1 divided by a very small positive number, and that is going to be a very large negative number. Okay. So, and you can check that out if you like on a calculator. Take negative 1, divide by a very, very small positive number, you'll get a very large negative number. And so this limit is going to be negative infinity. Now keep in mind this still means the limit does not exist. We're just specifying what type of DNE it is. Alright. Now let's take a look at this one. Limit as x approaches 1 from the left. So we'll write this as limit x approaches 1 from the left, negative x minus 1 cubed, and let's see if we can determine what that is. Alright, now as x approaches 1 from the left, that means that x is going to take on values like 0.99, 0.999, and so on. So if I put 0.999 in here for x, notice how we're going to get a negative number in here. And then we're going to cube it. Now when I take a negative number and I cube it, that's going to give us back another negative number. And it's going to be a small negative number. So the denominator is approaching 0 from the left side now, because it's going to be a very small negative number. You can put 0.99 in here for x and check it out if you want to. Now if we put, now as x is approaching 1, of course the numerator, that's still approaching negative 1. Alright, so what this is behaving like then is behaving like negative 1 divided by a small negative number. That's going to be approaching positive infinity, because when I take a negative number like negative 1 and I divide by a small negative number, this is going to give me a very large positive number. Alright, so this limit, it's going to be positive infinity. Alright, now the full limit, what's the full limit going to do? Well, since we have two different limits for the left and right hand limits, we're going to have to state that this just does not exist. All right. The only time we would state this as being positive infinity, like in the previous example, is if the left and right hand limit both exist, or I'm sorry, they not both exist, if they're both the same type of infinity. Okay, they would have to be the same type of infinity to put an infinity down here. All right? Now let's take a look at what the graph looks like down here and see if it matches with our information up here. So here's what the graph looks like. Let me just erase that right there. Okay. And yeah, we see that as x approaches 1 from the right-hand side, our function is going down to negative infinity, right? And that's what we saw here. As x approaches 1 from the right, our function is going to negative infinity. As x approaches 1 from the left, it's breaking up to positive infinity. And that's what we found right here. As x approaches 1 from the left, the function is approaching positive infinity. All right, let's take a look at another example. So here we have the function f of x equals negative 3x divided by x minus 2 squared. All right, so let's evaluate the limit as x approaches 2 from the right, the left, and the full limit. Notice in this case, the denominator is equal to 0 when x is equal to 2. So now let's take a look at the first one. So we'll write this as the limit x approaches 2 from the right of our function here, negative 3x. Now, notice that as x approaches 2 from the right, that means x is going to take on values like 2.01, 2.001, and so on. The numerator is approaching negative 6. Now the denominator, well, because of this square right here, and the fact that if I look at 2.01 and I put it in here, I'm going to get a positive number. This is approaching 0 from the right. Okay? So what this is behaving like then is behaving like negative 6 divided by a very small positive number. That is going to be a very large negative number. And so this is going to be negative infinity. Let's take a look at this one. Limit as x approaches 2 from the left. All right. Now as x approaches 2 from the left, well, the numerator is still approaching negative 6. The denominator, well, if x is approaching negative, 2 from the left, it's going to be a number like 1.99. Well, if I put 1.99 in here for x, I get a negative number in here, but then I'm squaring it. So that's making it positive. And it's still going to be a small number. So it's going to be a small positive number. So this is approaching 0 from the right side. So this is behaving like negative 6 over a small positive number. And that's approaching a negative infinity. This is a large negative number. And so our answer here is also going to be negative infinity. And so then we can state for our full limit down here, well, it does not exist. Both of these limits do not exist. We're just specifying a type of infinity. And down here, since the left and right hand limits equal the same type of infinity, we can say that this is negative infinity as well. All right, so there are our answers. Now let's take a look at the graph down here and see if it matches with what we found. So right here is the graph of the function. Just erase that there. Alright, and we see that as x approaches, this is 2 right here on the x-axis. As x approaches 2 from the right, yeah, our function goes down to negative infinity. That's what we found right here. And as x approaches 2 from the left, our function also breaks down to negative infinity, and that's what we found right here. Alright, so that concludes our discussion about evaluating infinite limits.